Let's take a look at question 21. So in this question, you start from the bottom, from this point P. Each time you can go to at drawing white squares. So it means you can go to any white square that's connected to P. So just repeat this again and again until you reach the point Q. They want to find out how many ways are there. So this is a counting root question. From P, when you go up, so you can go to the left, this is one way. Go to the right, this is one way. Then you go to the next layer, this is one. In the middle, so there are two ways to go here. So 1 plus 1, this is 2. Go to the right, this is 1. Then you go up again, this is 1. In the middle here, this is 1 plus 2, so equal to 3. Here, this is 2 plus 1, so this is 3 ways as well. For next layer, so there's no need to go to the left, because if you go to the left again, no matter how you turn right, you cannot get to Q. So if you reach this box, you cannot get to Q anymore. So there's no need to check this. Just check the one next to it. This is 1 plus 3. So this is 4. The next one, this is 3 plus 3. So this is 6. Here, this one is same number, so this is 3 ways. Then next layer. So 4 plus 6, this is 10. 6 plus 3, this is 9. Next layer, 10 plus 9, 19. Then this will carry the same number, so this is 9. At the last layer, 19 plus 9 equal to 28. So the answer is 8. Question 22. So in this question, when we input the number n, they will check if n is even, the output will be the number divided by 2. If n is odd, the output will be 3 times n plus 1. So after 6 steps, the final number is 1. They want to find the sum of all such integers n. This question is working backwards. So at the last step, this is 1. Or we can say this is the, okay, we label them. This is first step, second, third, fourth, fifth, and sixth. So at the sixth step, the number is 1. Now let's check what's the number at the fifth step. So if the output is here, n over 2 equal to 1, then n will equal to 2. 2 over 2 equal to 1. So n over 2 equal to 1, n equal to 2. But if it's from the other case, 3n plus 1, 3n plus 1 equal to 1, 3n is 0, n equal to 0. But this is wrong. N is a positive integer, so it can only come from the first way, where n is even. Then for the next step, so n over 2 equal to 2. N will equal to 4. For the second case, 3n plus 1 equal to 4. So this is, sorry, no, equal to 4, equal to 2. 3n equal to 1, this is wrong, n is not whole number. Then you check the third step. So this step, we will have two answers. If n over 2 equal to 4, n will equal to 8. If 3n plus 1 equal to 4, 3n equal to 3, n equal to 1. So this one, there are two ways. Then we check second step. So now when the number is 8, n over 2 is 8, n will be 16. But if it's 3n plus 1 equal to 8, this one doesn't work. N is not whole number, so here it can only be 16. Then if it's 1, this is same as before. When this is 1 here, this next step will be 2. So this is 2 also. Then you check first step. So when this is 16, n over 2 is 16, n will be 32. So we gotta check, does the second one work? 3n plus 1 is 16. Solving this, you get n equal to 5. There are two values here. Then for the 2, this is same as here, from 2 to 4. The last step, the original number. So 32, this one is n over 2 equal to 32, n will be 64. Then the next n over 2 equal to 5, n is 10. When this equal to 4, is same as before. When is 4, the next step will be 8 and 1. So here you have 8 and 1. In total, there are 4 different answers: 64, 10, 8, and 1. So just add them together. This equal to 83. So the answer is E. Question 23. So 5 different awards, they are to be given to 3 students. Each student receive at least 1 award. How many different ways can the awards be distributed? So each person receive at least 1. The distribution can be 1 student receive 3 awards. The other 2 students, they receive 1 award. This will be case 1. So how do we decide which person received 3 awards? There are 3 ways. Let's say the student, they are A, B, and C. So the one who received 3 awards can be either A, B, or C. So there are 3 ways to choose which student received 3 awards. After that, because the 5 awards, they are all different, So for the one who received 3 awards, you need to choose 3 of them out of the 5 awards. So 5C3. Now there are 2 awards left. So the next person received 1 award, so to choose 1. Now there's only 1 award left, so the last person is 1C1. So we find the value. 2C1 equal to 2, 1C1 equal to 1. So this is 20 ways. So 3 ways to decide who received 3 awards. 20 ways to distribute the awards. This is 60 ways. Now we look at case 2. Case 2 is one student received 2 awards. Then another student received 2 awards. One student received 1 award. So there will be 3 ways to decide who received 1 award. It can be either A, B, or C. So also 3 ways to choose. After that, so when we distribute the awards, first person, 5C2. Out of the 5 awards, he chose 2. Second person, now there are 3 awards left, so 3C2. 1 award left, so 1C1. So we find the value here. Calculate this, you get 30. So 3 ways to choose who received 1 award, and there are 30 ways to arrange the awards. This is 90 ways. So in total, this will be 60 plus 90. 150 ways. So the answer is B. Question 24. So there are some shaded small squares in the middle. They said when n equal to 24. So it means you have 20 more small squares along each side. This figure only shows 3. When you have 24 of them, 576 grid tiles cover 64% of the total area. So let's check how many borders are there. The border is d inches surround each tile. When there are 3 tiles, there are 4 borders. In this figure, this is, so when you find the total length here, this each of them equal to s inches each, so 1s. So this is 3s plus 4d. But this is only when n equal to 3. When n is 24, for this shaded region, it will no longer be 3s, it becomes 24s. So this is for one side. When you combine them together, it becomes a large shaded square. As for the total, so when it's 3s, there are 4d. The number of d is 1 more than the number of s. So when this is 24s, you will have 25 borders, so 25d. This is for one side of the large square. When you compare between the area, so for the shader, this is 24s times 24s. For the total will be 24s plus 25d times 24S plus 25D. So 64% is 64 over 100. 64, you can see this is 8 times 8. 100 is 10 times 10. So you can see 24S correspond to 8. 24S plus 25D correspond to 10. So we can get the simplest ratio, 24S over 24S plus 25D equal to 8 over 10. So 8 over 10, we can change it further. If you times 3 both on top and bottom, it becomes 24 over 30. So if you let 24S equal to 24, S equal to 1, then 24S plus 25D will equal to 30. This is 24 plus 25D equal to 30. 25D equal to 6. So D equal to 6 over 25. They are looking the ratio D over S. We let S equal to 1, so this is just 6 over 25. So A is correct. Question 25. So there are two rectangles, R1 and R2, and there are three squares, S1, S2, and S3. They said that the longer side is 3322 and the shorter side is 2020. They want to find the side length of S2. So let's say for S1, the side length is A. For S2, the side length is B. For S3, the side length is C. So here you can see this is to find the longer side. R1 is equal to A plus B. Then S3 is C. So this is A, B, and C. So if you got the longer side is A plus B plus C. This equal to 3322. For the shorter side, so look at here. This one equal to C. This equal to B. So this will be C minus B. So this is C minus B. So the total is A plus C minus B equal to 2020. You find the total here. From these two equations, if you want to find the value of B, which is the side length of S2, what you can do is you use the first equation minus the second. So first equation, you have A plus B plus C. Minus the second equation, you have A plus C minus B equal to 3322 minus 2020. So open the bracket. It becomes minus A minus C. Minus and minus become a plus, so plus B. And this number is 1302. So cancel A minus A, cancel. C minus C, cancel. So 2B is 1302. Divided by 2, this is 651. So A is correct.